Evening, Karen, Mega, can you hear me okay? I'm going to start desktop sharing. Welcome. I hope you had a great weekend. Can you see the desktop all right? Fix this. Very good. Welcome, Daniel. Before I start, do you have any questions? Thank you. Very good. Just a reminder, the team project is due Sunday the 25th. I'll go through the results from the test. We'll do the CG Confer question on Thursday. We're going to discuss Chapter 14. Just a reminder, don't forget to do 2 forum posts and replies. And if there's any questions on the extra credit programming project, we'll probably save that to the end. Okay, this is a good information for those that may have missed some of the assignments. You may do any of the missed homework quizzes. I take off 2 points for late, due Sunday the 25th. In other words, I'm not going to accept any work at all after Sunday the 25th. The only thing you'll be doing the next week would be the final exam. If you did less than 32 points on tests 1, 2, or 3, you may make up to that amount in extra credit work. Email me if you want to do the extra credit to earn those points. Last day to provide me the work is Sunday the 25th. Don't forget the final exam questions for the chapter assigned to you. I need these by Sunday the 18th in order to review them week 11. All work due Sunday the 25th. Boy, I said that many times here, including any homework you missed. Any questions on the notes I just talked about? Is that clear? Hi, Steve. Sure. On the first page, what I want to know is what operating system you're doing, all the team members and what they did, or if they didn't produce anything, say that as well. That's what I want on the first page. All the team members, what deliverable they did or didn't do. Something they were responsible and didn't do. Because they're going to end up with a 0. How is the project coming? Let's look at the team members again. I've double-checked the withdrawals against the list, and we're still okay. If I get a withdrawal, I'll indicate on here that that student withdrew. But what happens is they stay in class, but they don't do anything. And they just don't drop. So you might get a few of those. See, hi Albert. Any questions on the project? By now, what you should have is you should have the deliverables being researched and started to do rough drafts. That's where I think you should be on this project. But, you know, maybe like most students, and I was just as bad, you wait until it's due and then you do it. Okay. That's the project. Let's talk about the results from test 3. Basically, I threw out question 12. I got all kinds of strange answers. So I gave everybody 5 points. But if I made a mistake and skipped you, let me know. Send me an email or something that you did not get 5 points credit for number 12. Number 12 was the shortest seek time first, scan, look. The numbers were all over the place. So I just decided that it was a bad question. The rest of the test I thought was pretty well done. I'll show you the results in a second. Yeah, I know, Mega. Some people, you know, did get it right, but it wasn't enough. And I didn't want to, you know, what I started to do when I was grading it was saying, okay, if you're within, you know, 10 tracks, the number 10 within, and then I said, okay, some people are way off. Okay, if you're in 100, and then I said, well, this is really insane. So I just decided that it was a bad question. Next time I want to make it a lot clearer. So let's look at the results. Okay, we ended up with yeah, I could do that. Let me think a second. Hang on. I got to make a note of it to myself. Okay. We had 16 A's and 6 B's for a total of 22 out of 37, which I thought was really good. We got quite a few people got perfect scores on the test, and then they got fairly good on the optional question. What did you think of that optional one? Pretty good, huh? Genius. Ran out of time. Yeah. Well, let me show you. I have that one. Oh, Albert, I'm sorry. That happens. Remember, I said you probably should have, you know, copied it to Notepad or something. I mentioned that in the review. I was looking for something like this. The operating system starts. It started up A. Then A went to an I/O after 2 units. We started them. Then we started up B. B timed out of the 15, and got back and we started C that needed 5, and then we started its I/O here, but this I/O came back right here. This one here came back. This I/O was completed. So we came in and started the process right in here, right in this time slot, which is why B kind of got interrupted. But we didn't give it its full cycle, so we would have given it back to B right here. But then C's I/O knocked us out. So we went and handled that. Then started up B to finish its unit. It completed, got back to the operating system, and we scheduled A next. And A went for its next of its 10 units, and then it timed out. We got back in the operating system, went back to B, gave it its full 5, came back, and then let's see, gave C CPU, and then it wanted 6 I/O units. Gave the CPU to B, timed out here. Actually, it completed. B completed first. And then came back here, gave it back to A, and then A only got like 1 unit before C's I/O completed. We needed to handle that. Then we gave it back to A to finish up, and then we gave it to C to finish up, and then we finished at 70. So quite a few people were close. I think one student got this right completely. Yeah, Albert. Yes. Well, yeah, because the only way they could start is if the OS started them. I think I added that to the sample just to make it clear, but I should have added it to this wording, but I forgot to add that. But yeah, you always start with the OS. And that could be why some of you said it was 24 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, some of you said 24 units, and I didn't think about that. But I gave partial credit for the problem, and it looks like we had 2 people got it perfect. So that was pretty good. And then a number of you got points for it. And, oh, shoot. Sorry. Wrong one. I wanted to minimize this. Well, I have to go to it. Okay. And then the final point about this is, yeah, there were 13 actions by the operating system for 26. And yes, it could be interrupted, because that was the whole idea, is that that the operating system itself could be interrupted by a I/O completion. Very possible. Now, if the operating system turned off interrupts, then no, but I asked it could. I didn't say should. I said could. Yeah, let's look at that. What other causes then the I/O completion that makes a process go from ready state to waiting state? It would not go from ready to waiting. It would go from running to waiting, or running to ready, but I don't know how it could go from ready to waiting. There's no such state transition. Okay. A service request of some kind. Doesn't have to be an I/O. It could be malloc, right? In C, get me more memory. A malloc. That's not an I/O. It could be a message. It wants to send a message to another process. It wants to fork another process. All those are typical kinds of requests that would cause the operating system to put it in a wait state after it was executed. Okay? Did I answer your question? I'm not sure. Okay. All right, well, that was that one. So the results are really good, I thought. We had 37 people, but 4 didn't even do the test. So if you subtract the 4 from 37, you get 33, and half the class got A's and B's on this test. I was just showing you the cutoff for the grade. If you got less than 32, so if you're in this category here, once again, you can email me that you'd like to do some makeup to get you to 32 on that test. And what I do is I figure out how many points behind you are, and I ask you to pick a couple of questions at the back of each of the chapters that I assign, depending on how many you need. And you get a point for each one that you do, so that and you email me the question you're answering and your answer by the 25th of March. And I will add those points. But I don't put them on the test. What I do is I add them to an extra credit assignment that I specify where those points are coming from, so I can keep track of them. Any questions? Okay. Now, I thought those were good results. The issues that I saw when I was grading for those people that didn't do well was I don't think you did the review. You didn't review the Thursday session that I went through, because some of the answers I received, remember when we were doing the virtual address translation, that question, some of the answers I got were really strange. So you really need to review those online sessions that we do. Okay, you guys are okay because you're typically on the session. Questions? Okay. Chapter 14. It's kind of fun. I just brought this up just so that you could see some mechanisms for encrypting data. One is to use the XOR, and this was a good example. On Thursday, when I go through Chapter 15, I'm going to show you some other algorithms that you could use to encrypt data. And we'll have some fun with that. But this one I thought we would at least try. So I have like art, right? And art is A-R-T. In hexadecimal, art is 41 for capital A. A small r is 72, and a small t is 74. And if you took that 4 and put it in a nibble, it would be 0100. And here's 1 would be 001. So that byte represents, in ASCII code, represents capital A. So I did it that way so you could actually see it. So if I had this Rashmi, Rashmi was a student last year, and the capital R is 5.2, the small a is 6.1. You get the idea. So we put her code here, and we put a, let me think of how we did this. I can't remember what this was. This was something. What was that? Yeah, I can't remember what this code was. I think this was the keyword that we were using. That's probably what it was. I thought I did art, but it doesn't look like I did art. Oh, I could be. I could be XORing with it, so. Let's see. This here, not sure here now, XOR value of this. Oh, I think what I'm doing is this. This line here is the XOR of this, I believe. I don't know, it doesn't look it. The only way it would be different would be here. Yeah, this doesn't look, this looks like the same line to me. Except right here. I might have made a mistake here when I was doing this. Because these two, this line looks exactly like this. And then what I was trying to accomplish was taking art, that code, right here. This is art, as you can see, up to, looks like right there, and then it repeats. Art right there, and that's what it would do. Is it would, if you're going to XOR something like this against a keyword, you would keep repeating it if your keywords is less number than the actual text that you're XORing to. And then let me see what we got here. This looks like the final result, which is this back. I think that's what's happening, is that we're taking this and this, XORing it, and then XORing it back to get the value back. And the way XOR works, typically, it depends on which kind of philosophy you want to use. If you have a 1 and a 1, you can have a 1. A 0 and a 0, you can have a 1. a 1 and a 0. You can have a 0 or a 0 and a 1. You can have a 0. That's one philosophy, is if they're both the same, you set it to 1. If they're different, you set it to 0. The other philosophy is if they're both the same, you set it to 0. If they're different, you set it to 1. Either one will work. It's just which philosophy you want to use. Depends on the computer. Well, that's how that works. A simpler, not a simpler, this is a simple algorithm. Let's go into the chapter. Protection is a little bit different than security. The XOR really applies to the security side. The protection side is trying to, let me make it a little bit bigger. The XOR side, excuse me, the protection is the concept of how are you going to organize your policies and implement them to protect your system and your objects in your system. So we'll go through each of these types of things, and it's kind of fun to look at. It's not my favorite topic. You can get the feel for that. A couple of times I've taught computer security on CIS 108. Has any of you taken that? CIS 108? Computer security? Right, okay. Yeah, I taught that a couple of times. I haven't taught it in a while. And that was a lot of fun. I really enjoyed teaching that because you go through the whole aspect of security and protection and all kinds of nifty topics. But, you know, this one here is really applying just the operating system itself. The object-oriented came in the late 1980s, early 90s was this whole concept of object orientation. And you guys have taken C or C++, and they talk about it, or Java. I'd see that Bayo's typing. I was just waiting. No, you're not typing. Oh, okay. You must have hit the keyboard. All right. Typically, when you protect something, you have a specific name for it, and you have a set of operations allowed. You know, like maybe create or destroy or things of that nature. The guiding principle is the principle of least privilege. Programs, users, and systems should be given just enough privileges to perform their tasks. I kind of agree with that overall, especially if you're designing an operating system. But I also believe that you need to have access at a high enough level to allow change to this environment. Have you guys heard of backdoors? Okay. In chapter 15, we'll talk about backdoors. But whenever I developed a complex online system back in the 1980s and 1990s, I always designed a mechanism so that I could get in if the user somehow crapped out on the user security file, they deleted it or something of that nature. I still have that concept today in my applications. Yeah, you need it because users do silly things. Anyway, that kind of goes to this least protection. It's not a great idea. It's not something that you want to advertise, but the reality is it happens. Okay, you have a concept of domain, and you have access rights with object and rights, where the right set is a subset of all the valid operations performed on that particular object. So domain 1 has objects 1, 2, and 3, and it can read and write 3. It can read and write 1, and it can execute object 2. And you have another domain, let's say domain 3. Here, let's cover 3. 3 can print object 4, execute 1, read 3. Domain 2 can write object 2 and print object 4, and it happens that these two domains overlap on object 4 print capability. And you have to be able to create this kind of matrix concept, or I guess set-based concept, when you're designing your system in order to make sure that it works properly. So, for example, if you had, let me see if I can do this. If you had domain 4, and domain 4 included a part of domain 1 to execute, let's see, how do I do this? Yeah, domain 2. Execute, and it had, no, this, I don't see any good example here. What I was looking for was one that had like read only, and the other one that had write. So if you had a domain that included that, like we're doing it here, the least effective would come in place. So in other words, the write would not be allowed, but the read would be. Something like that. I hope that was clear. Typically in Unix you have two domains, the user and the supervisor. And the domain is the user ID in this case, domains which accomplished via the file system. Each file is associated with it. It has a domain bit or a set user ID bit. When the file is executed, the set is on, then the user ID is set to the owner of the file being executed. When execution completes, the ID is reset back. It's a good way to allow authority to a program. Example of Multics, another operating system, is you've got an I and a J domains with rings in them, and then you have this security level as what's included in each domain. So ring 0 is a very small, narrow domain. And then ring 1 includes ring 0. I don't know what that ring is. I don't know what that ring is, but ring n-1 includes all those. It's a nice way to implement. So if you're in, I'd say, ring 0, you don't have much. I mean, there's not much allowed compared to what you could be in the outer ring. It leads to an access matrix, and you gotta view it kind of this way, where the row represents domains and the column represents objects, and what kinds of things you can do to that object. So the access is a set of operations like read, write, or whatever that are allowed in the domain. So let's take a look at it. So I've got object F1, F2, F3, and then I got a printer. A domain, I think F is supposed to be a file. So file 1, file 2, file 3, or it could be, I guess, a folder. No, you don't typically execute folders. It's a file. Let's say it's a file. We have 3 files and a printer. Those are the objects we're dealing with. And the domains, we have 1, 2, 3, and 4. So F1, domain D1 can read F1 and read F3 files. It can use the printer. D3 can read F2 and execute F3. And D4 can read and write file 1 and read and write file 3. And that looks pretty straightforward. The problem comes into is when these start to overlap. Okay? We'll see that in a minute. So if a process in a domain tries to do an op on an object, then the op must be in the access matrix for that domain. It can be expanded to dynamic protection, where operations to add, delete, access rights, special access rights. So special would be the owner. So you could have the owner of an object and then copy the operations from one object to another object, or you might want to control certain access rights. So domain I can modify domain J's access rights and actually change them. And then finally we can transfer, switch from one domain to another domain. So when we introduce this, the complexity of our system is phenomenally increased. Okay? The original, I'm trying to remember NetWare back in the 1980s. NetWare had, I think, 8 operations. And it was something like read, write, delete, update, create, I must be missing one. Search, because if it was a directory, you need to be able to search it. And the last one was like control, where if you have the control, you can set any of those other 7 actions. And that became the model that went into networking from that point on. And we have these simple accesses, and you can see that too. Let me just move this a little bit. You can see the concept of that in, if you look at security here, you see you got full control, modify, read and execute, read, write, and special permissions. So these concepts came from NetWare way back in the 1980s or so on file servers. Okay, well, I'm going to keep going. Access matrix design, and it got real complicated, and what got more complicated was when Microsoft came out with Vista. They really increased the complexity of this mechanism. But you need to understand these two concepts. The matrix design really needs to be separate mechanism from the policy. It sounds a little strange, but that's the way you'd want to design your system. So your mechanism is it provides the access matrix plus the rules of that matrix. And it ensures that the matrix is only manipulated by authorizations and the rules are strictly enforced. That's the mechanism. The policy is the user needs to dictate the policy. What group is allowed what kind of access? Who can access what object in what mode? That's the policy. And there's a whole list of policy type stuff. For example, you could set up the policy on your local machine in Windows to have users log in, force login changes where the login name has to be changed every 30 days. Login password, sorry, has to be changed every 30 days. That kind of thing is a policy. And like I said, there's a ton of policies available. All right, so let's implement the access matrix. So each column is an access control list for one object. We went through this. Domain 1 can read and write, domain 2 can read, domain 3 can read. Each row is the capability list. It's like a key. So for each domain, what operations are allowed? Object 1 you can read, object 4 read, write, and execute. Object 5 read, write, delete, and copy. And here's our figure A with domains as objects. So I'm going to have a domain, and that's my domain, and then I have my objects, and then I have my domains as objects. Okay? So that's what he means by domains as objects. Is we know domain 1, 2, 3, and 4, but we also use it as an object in this example. So D1 is allowed to be switched to D2. So now you can do the stuff that D2 is allowed to do. And D2 is allowed to switch to D3, but once you're in D3, you're not allowed to switch anywhere else. But you are able to read file 2 and execute file 3. Okay. Now going back to domain 2, if you switch to domain 4, you're allowed to read, write, and switch back to domain 1. So now I could go from domain 1, right, to domain 2, to domain 4, to domain 1. And repeat the cycle. Do you think that this could become very complex quickly? What do you guys think? Yeah, and what would happen is if you're allowing this to occur dynamically, it's very possible that you might do something like this. You have a control ability, right? The ability to control how these objects here are, what operations you're allowed, and you say, okay, I'm going to go to domain 2. I'm in domain 2, and I'm allowed to take this switch away from D3. So now I can't get to D3 anymore. So that dynamic stuff is going on in the security. Wow. Okay. Now, if you allow copyrights, right? Let's take a look at it. So I got my objects, my 3 files, and I've got my D1, which I can execute, file 1, and write. And if I am allowed to copy something, like copy the read of file 2 to domain 3, I can do that. If I'm allowed to place a write into domain 1 for file 3, I'm allowed to do that. So with copyrights, you could have some issues. Let me see, we got, yeah, I think this example is showing that we're starting with these and we're ending with these happening, these being copied. Oh, the example with owner rights. This is owner. Now, owners have the ability to allow copies, not just the previous one. I missed that. With the copyrights allowed to copy, I can do things like that. But if I'm the owner of an object, I'm also allowed to do things like this. So you add another level of these owner rights. Let me see, did I? Let me see this. Did I show that here? In Windows. So we go to Advanced. And we go to Owner. We can do more things to this if we had more control, like I can edit this. And I have other groups. I can use other groups and things and make assignments. And you see all the select the objects. Let's look at the object types. I got built-in security principles. I've got groups. I've got users. I can select those, right? And then apply what I want to them, to that object. It gets real. Oh, here's another advanced. So I got another advanced topic of objects locations. I can find all kinds of stuff. It just goes deeper and deeper. I'm going to cancel that. But you can do a lot as an owner. Oh, and then they have the concept of an effective. This would be like what's really in effect. Okay, these privileges are what's in effect. So on this object, which is the file, this file, it's a text file. Of course, I have full control. No, it doesn't look like I have full control of it, even though it's my file. And I'm the owner of it. See, I'm the owner of this object. Me here, user on this machine. I'm the owner. Okay. All right. Well, I just wanted to illustrate how complicated that could be done. And here's another modified access matrix of the figure. So we have control, which allows us to do stuff to domain, I guess, domain 4. I'm allowed to control domain 4. So I can change some of these rights in that domain. Okay. You can use protection to non-file resources. Solaris is no longer around, but Solaris 10, I do recall, provides role-based access control to implement the least privilege. So the privilege is the right to execute a system call, so that's a non-file resource, or use an option within the system call. This can be assigned to a process, and then the user-assigned roles are granted access to the privileges in the program. So the user is involved in this too. And that's called role-based access control, based on your role. So it would look like this. So a user has role 1. It could have more than one role, but it has a privilege 1 and a privilege 2. And the role with 1 privilege is to run a process. They can execute a process. Now this gets a little more complicated. You want to be able to revoke the access rights. So you have your access list. You want to delete the access rights from a list. And two kinds of ideas. One is a simple and one is intermediate. Simple means it's not in use right now. That particular access right is not being utilized by the system. Intermediate means it's being utilized typically, and you want to correct it right now. Okay? So simple and immediate. Simple typically means that access right is not being used. It's not opened, it's not being accessed. Immediate typically means it's being used and you want to stop it right now. Scheme required to locate is the capability list. Locate a capability in the system before the capability can be revoked. Okay, so that's this capability list. You got to have that list of what's being used. So you got to be able to reacquisition that. You have to adjust your pointers. You probably have some indirection going on, and you have some keys. And you could use any of these methods to create your list. So let's look at the capability-based systems. I'm really not that familiar with Hydra. Are any of you ever worked on a Hydra system? I haven't worked on a Hydra, so I'm not quite sure what this operating system does. I didn't do any research on it. Anybody else ever see one? Mega hasn't? Yeah. Yeah, I haven't either. Well, maybe the concept from this is used in some systems. I just haven't heard it. It has a fixed set of access rights known to and interpreted by the system. Okay, that's good. Interpretation of user-defined rights performed solely by users' program. System provides access protection for those rights. So it's fair, to me that seems fairly straightforward. Cambridge CAP system, data capable. Provides standard read-write execute of individual storage segments associated with an object. So they talk in terms of storage segments. So like pieces of blocks on the disk or in memory, something of that nature. Software capability interpretation left to the subsystem through its protective procedures. So one's a data capability version and the other is a software capability version. Okay, let's see if we can see anything else. Language-based protection. You use a language in a high level, like a C or something of that nature, to describe the policies and the use of resources. Has anybody used LDAP? Have they talked to you guys about that? Anybody in your programming world? No. It's a local access protocol that through a program API you request, like on Windows, you request access to a system. And typically that's called LDAP. So if they're using Active Directory, it would be the local Active Directory protocol, LDAP, Local Directory Access Protocol. All right. Well, we're not using Active Directory. Typically, servers have the Active Directory. Windows has an Active Directory scheme underneath it, like this Windows. Let me think about that a second. I'm not sure Windows 7 is using that. I just don't remember when it was implemented. We'll have to, you guys that are doing your security, right, on your projects, make sure you do an investigation if you're doing Windows in the Active Directory. When was that implemented in what operating system version? I'd be curious to know. Okay? If anybody's doing that in your projects. And the same thing would be if you're doing security in Unix or Linux. What kind of language-based protection is available? So that would be a good thing to explore. So Java, I think everybody uses Java. I know we're using Java right now. This Blackboard that's doing our session is written in Java. So the virtual machine is handling that. It's not that, I don't think it's that complex, but if a library method is invoked that performs a privileged operation, the stack is inspected to ensure the operation can be performed by the library. So it's keeping track of owner and execution on that virtual machine. So here's an example. You have an untrusted applet, you have a URL loader, and you have the networking going on where you open an address. Okay, so get URL could be a class, or open address would be a class. Load from a specific port. So all those would be whether they're privileged or not, check permissions. You can implement that. Has anybody done the class at sockets? I think it's the TCP/IP class where they do socket programming and they look at TCP/IP functions and features and networking and that kind of stuff. Has anybody taken that one? No. Okay. All right. Oh, you're waiting for that class. Hang on a second. I'm just going to try and look it up. I think it's 75B. Yeah, 75B, Internet Programming with TCP/IP. Yeah. Yeah, I was asked to teach it one time, and I looked into it, and then I said, well, it's awful low level, and I really didn't want to spend the time to get at that hardware level. So I didn't teach this. But anyway, it's interesting. But that's the kind of stuff that you're doing, is you're opening sockets and you're using the TCP/IP protocol. And that's it. This is a short chapter. Was there any questions? The main thing to learn out of this, I think, is, and if you look at the homeworks I gave you to do, let's do that. Let's take a look at the homework questions I gave you for this. Really does not have a lot of meat in this particular chapter. It's more like an overview. Oh, it's not like that. Sorry about that. I've got the presentation open. And what I wanted was the quiz question. Oh, they're extra credit. In other words, you don't have to do these unless you want to get extra credit. So there's and it's 8 points. All of the homeworks are worth 8 points. So if you wanted to do them, it's extra. Because they're all worth 0 points, and I give you 2 for each question you answer. What's the main difference between capability list and access list? You can answer that one. What protection problems arise if a shared stack is used for a parameter passing? That one you might have to do a little more investigation on to answer. But it's in the book. I know that, more detail. We didn't cover it in the slide presentation. We spent time. This is, in my thinking, understanding this is probably the best part of this chapter. Question 3. Yeah, and I kind of alluded to the weaknesses of implementing access matrix using capabilities that are associated with domains. I didn't really talk about the strengths, so let's do that. Let's go back to that slide. So part of the idea of capability based is you have a fixed set of access rights known to and interpreted, right? Simple to implement. That would be an asset. What's bad about these is the scheme you're going to have to use to revoke access rights. What scheme are you going to use? How are you going to implement that? That's a weakness. So we answered some of those questions. But what I wanted to do is this one here. If you understand how this works, I think you've got the idea of an access matrix. To implement something like this, it gets more complicated to work properly. And I'll try to show you that. Let's see, did I finish though on the, before I do that? Where are we? Hang on a second. Yeah, I finished off. So I talked about this with you guys just now. This one is the one I really want you to spend a little time and think on. And then this you're going to have to get out of the book. I'm not going to talk about this. And this, I did kind of talk about access lists and capability lists. Access lists are domain and objects. Okay, I covered that. I was going to illustrate something. I forgot what I was going to illustrate. Oh well, it'll come back to me. Oh, I talked about it here. The issue is, if a domain, like, how can I say this? Oops. If a domain allowed I want to go to that set. At the very beginning we talked about this one, this concept, where if I'm in domain 2 and 3, it's possible that you could, as a user, you could have 2 domains associated with you. And if that's feasible, then each domain has a different, maybe for the same object, has a different authorization. You're going to have to take the least one in that. And that was the whole concept at the beginning. What was that we want the least privilege associated. And when you have these a user associated with 2 different domains, you'll have that kind of issue. Now, the simpler ones, right? This capability list is, I've got, for example, I treat. Let me do it this way, because I'm almost done with this topic. I mean, it's not that. I mean, what I would like you to do is do a search like I did on Windows, right? And dig down into a file, right? Go to security and just examine what's going on in that. Take the advanced view, go in there and look at effective permissions, look at owners, edit it, right? And you can make changes if you, well, I wouldn't make changes, but you can take a look at that, see what that's like. Take a look at other objects, right? Find other object types, just like I did. And just kind of pick a file that you don't care about, and you can play with its permissions. And that'll teach you the idea of the access lists. Okay, that would be my recommendation. Now, let's do this. I was going to give you a simple example. And I'm taking this from a simple operating system. So let's say if I'm going to implement protection, and I'm going to have groups and users, and I'm simply going to do files. Okay, so the first question I would ask is, can a user belong to more than one group? And you would have to decide that as an operating system design. Okay, if the answer is yes, then it's possible that a file in one group can be updated, and in the same file, in another group that the user has in his group, can be read-only. So now you have to implement the least or the most. You have to make a decision. I personally don't like the least approach. I guess I like to touch everything. But update would be my choice. So you would have to have that choice. I kind of disagree with the philosophy here. So there's another philosophy. So the OS must decide to use least authority or most authority. So you're going to have to make that decision. Okay? So these are the kinds of things that you think about when you're designing your system. And then you got to think about, well, what other objects, what besides files, in other words, objects, do we need to protect? Okay? So those are the questions and kind of things that go with this chapter. And that's what one mechanism that's implemented. Any questions? How are you guys doing out there? Are you guys planning to do the extra credit homework? Okay. I would recommend it. Well, you don't have to, Steve. Yeah, I look at it that way, Dale. 3 points. I mean, what's worst case? I mean, if you put, kind of an answer I don't understand, instead of getting 2 points, you get 1 point. Oh, Mega. I give A+ if it's beyond the 400 or 300 points. Let's look at the syllabus. I can't remember if we have 300 points or... well, that's funny. I don't see the syllabus. I see all of that. Where the heck is my syllabus? It got removed. Wow. Yeah, yeah, it's under home, but it's a file, and I did copy it there. That's crummy. Oh, I wonder if that happened. I had to update my file to include these student learning outcomes thing, and I might have screwed it up at that time because it was there before. Let's see. Total points is 400. So if you get more than if you get 400 or more points, I typically give an A+. Because it's more than the requirements. I don't give B+ or C+. I don't tend to do that, or C-. I don't tend to do that. You might get this though. Let me see, what would I do? Okay, what I do at the end of the year, when I look at the total points, right? I look at the total points like I'm looking at total points for this test, and I see that one student as like 1 or 2 points away from a grade change. I may move them up, and then I would give a minus. So I'll do that if I see, they've been really trying, but they just were short of a B, let's say, by 2 or 3 points. Well, in my thinking, that's enough to move them up to a B minus. So I would give a minus in that case. Same thing with if they're sitting between an A and a B and they're only 2 or 3 points away from an A, I would probably move them up to an A minus. Any questions? Yeah, the optional are worth up to 8 points, right? Each of them, it's just like your homeworks. The maximum is 8 points. And each of them have 4 questions, 2 points each. Oh, Mega, I don't know. That doesn't sound like something I would do. Yeah, like I said in the past, I've taught this class at least 50 times at the end. I've got to do 50 because I used to teach it every quarter when I first started back in the early 80s. It was offered every quarter for maybe 10 years, so that would be maybe 30 or more, well, maybe more than 50 times. I can't remember now. 40 plus, yeah. Oh, the other thing you can get extra credit for, wow, I'm glad you mentioned that, is right here, the class evaluation. I forgot how many points that earns. Let me preview it. It's on the number of questions. Oh, that's worth 10 points. There's 10 questions. So here's extra 10 points. So it'd be worth doing. Yeah, and the thing I'm looking for at most is any suggestions. That's how this course has become what it is right now. That's why you have 3 tests versus 5 when I first started. That's why you have a team project versus everybody doing a project. That's why you have 4 homework questions per chapter rather than the 8 originally done. What else has changed? Oh, quite a bit. So any suggestions? Other schools can see what, Meg? I'm sorry, I don't know what you mean. Oh, the A+. Oh, I see. Okay. Well, I'll mention this again about the class evaluation. I think it's only open, let me see, I only opened it for 2 days. I mean, it's not like open now. Let's see when it was open. I think it's open Monday and Tuesday of the final week. I don't see it there. There it is, surveys. Yeah, it's open on Monday and it's closed on Wednesday. And I'm pretty sure I put that in the. I thought I put that in the syllabus too. Okay. I'm sorry. One more check. I'm running 2 classes this quarter. That's why I'm kind of not sure. But you get to write your own final exam questions. You're very fortunate. My other class, my Visual Basic class, they get to see my questions. I was wondering if I would mention something about the survey, how many points that was. Doesn't look like I put it in. No, it doesn't. I didn't put that in. Well, don't forget to do these topics, guys. They're worth 40 points. Your team project's only worth 35. No, I'm sorry. I didn't put the value of the survey, but it's important to me. So I would say it's worth 10 points. And it's extra credit. Okay? Any other questions? Pretty much done for this evening. I'm going to save this. I'll repost it. Oh, I guess I'm going to close. Is anybody going to do the extra credit programming project? Any of you guys going to do it? No. Okay. That's fine. I mean, it's not required. I was just curious. Yeah, last year I had, let me see, I had 2 students, I think, do it. Let's see for a second. Special OS project. Yeah, these were the submissions last year. Yeah, I had 2 students, and they did a pretty good job. Let me see. Yeah, he did something called Scala, which I wasn't familiar with, but I was familiar with Java. That was my note. He did it during the online session, where this one actually wrote C code. And this program Let me send it to Notepad. Not very long. So there's something else going on. Oh, this is it. That was his main program, and then I think this was the operating system. No. Yeah, this looks like his system, and I don't know. Oh, this was his comment. This was his comment of what he was trying to implement. And his code was pretty good. And it worked. I saw his results. So he did a pretty good job. So it's possible. Hers, yeah. I'm sorry, her. She did a pretty good job. Tatiana. Correct. Okay. Well, if there's no no one's have any questions on the extra credit, we can call it an evening. Thank you all for participating. You guys did great. Have a good evening, and we'll see you on Thursday. And then we'll spend a little more time on the security side, because there's a little more meat into that one. Have a good evening. I'm going to log off. Good night.